Mercury, commonly known as quicksilver, is a chemical element whose symbol is Hg. It is the only metallic element liquid at standard conditions for temperature and pressure. It is commonly found in thermometers, float valves, fluorescent lamps and in other devices. Between 7,000 and 9,000 metric tons of mercury are emitted to the atmosphere annually, some from natural sources, like volcanoes or emissions from the ocean, but roughly 2,500 of these tons have instead a direct anthropogenic origin, being that from fossil fuel combustion, small-scale gold mining, or cement production facilities. Among the most egregious offenders, mercury is a pollutant of global concern, due to its high toxicity and its characteristic of bioaccumulate in living organisms, and biomagnificate, ultimately affecting organisms and the human health. The effects of mercury on living organisms are the ones of a neurotoxin. The severity of such effects depends on the chemical form of mercury, the duration of exposure, and the individual vulnerability. Methylmercury is more toxic than elemental metallic mercury, and has higher health effects on vulnerable population like pregnant women and unborn children. Also, duration and route of exposure, inhalation, ingestion, or dermal contact may cause severe poisoning. Mercury emissions know no national or continental boundaries. Once released into the atmosphere, mercury can travel for thousands of kilometers before coming back to Earth in rainfall or in dry gaseous form. Surveillance of sources of emission, patterns of deposition and mercury levels in the various environments and ecosystems is paramount in order to be able to minimize human exposure, emissions, and food chain contamination. But there are still many large swathes of the planet, often remote, inaccessible areas, for which we have no reliable data, that all the same contribute to mercury emissions. In this regard, Earth observation alone is not sufficient, at least not with current technology. We need to integrate remote and in-situ observations with ancillary data regarding meteorology and the composition of the atmosphere. Current efforts at European level are aimed to develop a transnational environmental observation system in support of European and international policies, through the integration of real-time monitoring data from various platforms, modeling tools and an advanced globally infrastructure for data sharing and interoperability. For tracing mercury pollution, there is the need to integrate in-situ and satellite observations for better understanding of the global cycle of both mercury and persistent organic pollutants, the so-called POPs, at continental and global scales. We need to identify mercury hotspots deposition areas, through in-situ wet deposition measurements and satellite observations, for mitigation and for informing policy decisions. But generating environmental data is only useful if the data is readily available, in an appropriate format, to other researchers, the public and those tasked with implementing or defining environmental policies. Therefore, we have worked on a way to harmonize metadata production, archiving, and sharing, to validate regional and global scale models, based on in-situ and space observations assimilation, and to create advanced web services for data discovery and exploitation, making information on environmental and human exposure accessible, to allow for joint interpretation and assessment of human risks. We created a thesaurus, to better organize domain concepts, made of specific terms, to allow the metadata addition and facilitate information searching. Most of all, we support policymakers and stakeholders in the implementation of major international treaties, like Minamata and the Stockholm Conventions, and international programs like UNE's Convention on Long-Range Transboundary Air Pollution, and EU research infrastructures. Besides, we contribute to the GEO work program via the Global Observation System for Mercury flagship, GOES-4M. All those big data generated by in-situ or satellite platforms are now being collected and archived with a plethora of systems and instruments. This makes extremely difficult the sharing of data and knowledge to stakeholders and policymakers for supporting key economic and societal sectors. So, we saw the need for a commonly shared data catalog and for data processing tools. We did so through eShape, a flagship European project ensuring the optimal implementation of EuroGeo, a unique initiative that brings together decades of public investment in Earth observation and in cloud capabilities into services for decision makers, citizens, industry, and researchers. eShape aims to streamline the access to key resources, like knowledge, technology, markets, and capital, allowing researchers, developers, and industrial actors to deliver services that bring concrete benefits to a number of key societal sectors. This project will enable and accelerate a breakthrough in the European Earth observation sector, and the downstream markets that benefit from Earth observation services. It will deliver concrete, Earth observation-derived benefits, with, and for, users through a rigorous co-design. It will allow Europe to position itself as a global force in Earth observation, leveraging Copernicus data, making use of existing European capacities, and improving user uptake of the data from geoassets. In the E-Shape framework, Pilot 2.1 aims to contribute to the effort toward mercury pollution monitoring, analysis and prevention. We are already benefiting from the activity of two ERA-Planet projects, namely IGOSP and iCube. Now we are integrating and linking these data and make use of advanced technologies in the field of Earth observation, together with real-time monitoring data from various platforms, to integrate and validate Earth observations and to grow the number of surveilled areas. Our pilot has a vast potential user base. Our primary key users are farmers, agri-consultants, agricultural cooperatives, fishermen, and industries. Being able to check for mercury contamination of the soil is paramount for the agricultural sector, especially while the cultivated areas expand more and more to feed a growing population. But our pilot has a larger scope, so it encompasses the needs of the general population as well, that has a legitimate interest in knowing the healthiness of the environment they live in. Least but not last, our most important reference public are policy and decision makers, people who need all the relevant, scientific-based and verified information they can get. In order to take the right choices, they need not just data, but relevant, easily interpretable results that can take into account even the cost-effectiveness of various policy alternatives, tools that can be rigorous, but at the same time easily accessible and operable, to generate alternative policy scenarios at the click of a button. To cope with the above requirements, during the last 2 years the GOES4M Knowledge Hub was developed. It includes tools to discover and access available in situ HG datasets, satellite observations used in regional and global scale chemical models, the Hermes emulator of modeling outputs for different anthropogenic emission scenarios, and scientific references to the adopted methodology. The Knowledge Hub provides knowledge on mercury fate at global scale and shares knowledge on mercury pollution and mercury fate. Datasets and services are available by means of graphical user interfaces and API services for machine-to-machine interaction. By means of the web-based catalog, datasets can be discovered by using different searching tools, employing also maps and keywords to improve its effectiveness. Furthermore, the Knowledge Hub has been developed to provide final users with an effective user experience, by means of a dashboard able to simulate different scenarios about mercury fate in a quick and interactive way. Numeric results of the Knowledge Hub are strictly coupled with confidence intervals. Provided predictions and widgets in the dashboard are linked to published papers to supply scientific-based evidence about the provided outcomes. The results of the pilot will also be made available through the Geo Knowledge Hub. Furthermore, the Knowledge Hub has been developed to provide final users with an effective user experience, by means of a dashboard able to simulate different scenarios about mercury fate in a quick and interactive way. Numeric results of the Knowledge Hub are strictly coupled with confidence intervals. Provided predictions of Hg concentration in the ocean box and concentration of total Hg in biota are provided through simple graphical user interfaces. The results of the pilot will also be made available through the Geo Knowledge Hub. The Knowledge Hub has been developed using an iterative approach and is currently available through a web browser at goes4m.org. With regards to policymakers, cost assessment is one of their main necessities. Funds are not without limits, so they need to be spent wisely. Therefore, it is essential to be able to evaluate, with a good degree of certainty and on scientific basis, which measure is more effective to implement, considering the costs involved. This is exactly what our Knowledge Hub can do. Thanks to a statistical emulator, linked to actual data, a policymaker can run different scenarios and choose the one which is most cost-effective. If you are a decision or a policymaker, please contact us for a demonstration of what the Knowledge Hub can do for you and your organization. If you are a farmer, a fisherman, an agri-consultant, or your work is with agricultural cooperatives or industries, contact the help desk to better understand why being able to check for mercury contamination is so important for your work, and not just for your personal health, but as well the one of your companies. If you are nor a researcher nor a policymaker, mercury pollution can look in your eyes a remote concern, but it is a danger more actual than ever. Without knowing it, you might be planning to buy your next house on contaminated land, drinking polluted water, or eating mercury-tainted fish. A nearby landfill can be leaching mercury into the water table, or a coal plant can be releasing it into the air you and your family breathe. Publicly available, web-based services like the Data Catalog and the Knowledge Hub represent a unique source of information that can be used to build applications and services you can check to easily assess the healthiness of your surroundings. For more information, to understand the many ways mercury can be dangerous, and what can you do to minimize both exposure and emissions, go to our website. You will find the link in the description. Finally, if you are a fellow researcher, please contact us. Should you be interested in asking more questions or into joining us, supplying us with data or sharing your results, if you need more details on how to do so, please contact us at the link in the description or go to the eShape website, also linked down below. Thank you all for your time, and remember, mercury pollution is a planet-wide problem that needs planet-wide solutions. All of us need to pitch in to be able to live on a cleaner, better, healthier planet.